So this evening, we're going to continue with functions. The group activities, we'll dive right into it. One is a math question, pretty easy. Other one's dice. We're going to talk about the random module at first. Let's take a quick look at that. Dive more into functions here in a second. Pull up the shell. Let's take a look at random. First, go ahead and import the module of random. Do a dir on random to see what we get with that module. All kinds of fun stuff. Some of your best friends here are shuffle, random integer, where else? Choice is a good one. Choices, sample. They all have a lot of these. I use random integer pretty consistently. Now, is it truly random? Well, you give it boundaries to be random, right? So you got to keep that in mind. But when would you use this? Let me see. Let me answer something over here. Okay. Well, anytime you need a random number, right? That makes common sense. You could do things. I think your book has something along the lines of import random and say we're going to do a random integer. For every, we'll say number in range, and we'll just say stop at 10. So we get 10 items, right? I'm going to say x equals, we'll say num. Should we? Let me see. I'll just say x, it's fine. We'll say rando for fun. Rando equals, and we'll say call on our random dot rand integer. And here we could say, give me a random integer from 1 to 1,000 or 10,001, right? So random int will select an integer between that range, store it in rando, and we'll print rando. So save this. Just say, we'll go lesson 4. And let's say random. Good enough. Hit F5, you'll see that we get pretty wild, consistently numbers over 1,000. Well, what happens if we run it again? Okay, so there's a different variance. And it actually picked the last one, which is pretty interesting. So it's not like range. It doesn't stop at 10,000, 10,001. It'll carry on. It's actually the last number in your range. So that's helpful. The better way to import this, if you're just going to use rand int, is from random import rand int as, then you can give it an alias, rint. So instead of typing all this, you could just put rint, comment this out, and see it still works. So what this does is instead of importing the entire module, you only import the one method that you need from the module, saving memory. Especially on some of these larger modules where you're only going to use one or two methods from it and there's thousands of them, you don't want to import everything, right? You can get away with importing just what you need. So that's helpful, right? Random range is another one, which does have a start, stop, and a step. And that'll give you, let's say from random import rand range, we'll just do this right here. Random range, and we'll say rrang, rrang, right? That's good enough. So we'll pull that in, and we'll say rando equals rang, and we'll start at 100, stop at 500. Let's go 1,000. Let's go 1,200. And we'll count by 20. And now we should get 10 items between rand range, right? Oh, what happened here? Random range. Let's see what I misspell. It's rand range. There we go. So syntax error on my part. So here we have our range from 100, stopping at 1200, counting by 20. We want a random number between that range with to be in the count by be able to be divided by 20, and that's exactly what we have. Cool. Two cool things with random. Random choice is kind of cool. I don't think it's covered in this chapter, but I just want to show it to you really quick. Let's see. We'll just import choice as itself. That's fine. Now this is kind of cool because don't necessarily need this. Let's throw in a list. We'll say my list, and we'll equal 1 comma 3 comma. That's good enough, right? Pretty generic list. And we'll call on print choice, and then we'll give it my list. And you see it selected 3. It randomly selected 3 from your list for a choice. You can get tricky with this. You could toss choice a range like we did earlier down here. We could give it a range. We could do all kinds of fun stuff. But choice will select something randomly. So it doesn't have to be integers either. It could be, say, something like a rock. Maybe if you had some paper, and if you had one of those scissors, right? And you ran that, it'll randomly choose a selection for you. So in essence, you could do something like CPU choice equals choice my list. And then print CPU choice, just in case you're wondering. And now you randomly selected from your list rock. Let's do it again. And now you have paper, so on and so forth. It's only a random choice from the items in your list. Cool. Could be handy on this individual lab. So choice is fun, range is fun, random range, and of course, random integer. Awesome. All right. Let's talk more about some functions. Get rid of this right here. So last week we talked about some basic functions, how to define a function, how to pass it a parameter, an argument, so on and so forth. Now, with this knowledge comes great power, right? You can have a blast with this stuff. You got mainline logic, all kinds of fun stuff comes to mind. One thing to keep a grip on is what functions can perform what to certain arguments or take certain arguments. There's such thing as keyword arguments, default values, a little bit more complex. So let's define a function, and we'll just take the training book called say. Well, what do you want to say? Well, our function is going to have a message for one parameter or an argument, right? And then we're going to pass it how many times? And we're going to say equals 1. And then here we'll run a print statement, and we'll say message times times. Okay, makes sense, right? And we'll actually run it. So what we're going to say is say, we'll just pass it hello really quick. In theory, the default value at times is 1. We didn't call on it here when we defined it, so we only have the message. And we should get hello times 1 is hello. Okay, we're going to take the same concept and we're going to define the other argument times equals, and we'll say 5. That'll change things. And on the very bottom, we won't define our message. We'll just say times equals 7. And now we have our first function ran, say hello. Default value is 1. Hello times 1 is hello, and that's highlighted over here. Our second is hello with times. Change the default value to 5. So hello times 5. 1, 2, 3, 4, 5. And here we get an error. We say missing one required positional argument message. I didn't call on message, and I didn't give it a value. Well, what if we try it this way? Message equals hello. Well, that works just fine. Well, what if I took this and put it at the end? That works just fine too. So just because it says message and times, as long as we fill in the default value by calling on the actual parameter name itself and filling it in with a value, and then changing times, it'll work. Cool. So that's helpful in some scenarios or when you're feeding multiple arguments to a certain function you built. Super handy. Say if you had one function called game, and one was CPU choice, and one was user choice. Well, those could both be functions that return a value and then feed this other function those parameters to perform whatever task on them down here. So you could create really efficient, really functional programs with just a few functions passing values to each other, allowing the individual function to be really good at one thing and reusable code on that. And you could do multiple keyword arguments as well. You could say things like times is 1 and then spaces equals 0, and then put spaces in here. You can get really tricky with this stuff. But your book has a decent example, and then we went over it pretty well. Now, if you wanted to write what this particular string does, this is a good lesson to always document your code, right? Well, Python is sort of self-documenting. You could say what it does here like a help line, like prints a message and default value of 1 time. So I got my 3 lines in there. Everything's good. Let's add a little note here. Output, right? No big deal. And hit save, hit F5. Everything's good. I'm going to go over to the shell. I'm going to do a help on say. Well, now you see that help on function say in module main. Say, it has our message and times. Now it has our print statement here, which is our document string. Prints a message and default value of 1 time. You notice it did not print our comment because our comment is not part of the document string. So that's why some people say Python is sort of self-documenting. Well, it is, but you have to, put in the triple quotes and type as much as you want to find your own functions and add in the help. You could even, do a new line here and say how to use it, and give it a, like, say, an example. We could type an example here. We'll just do that really quick. Save F5, reload it, get another help on say, and we'll see that it has how to use, or you can put an example and give examples of how to use the actual function. So these document strings, they're only as valuable as what you put in them, right? It's good practice to fill in what your functions do, because sometimes you may not remember what you originally intended to do with your functions. Now, there are other things that functions can do. Functions have a part of our, let's see, import statement. Let me see, math and pi. Yeah, I'm not really going to go into the pi stuff. It's pretty self-explanatory in the book. Random module we already covered. Let's talk about the mainline logic challenge, right? So now before we run this, let's say we built a main function. It's always best practice to build a main function and put your says under your main. All right. And then right here, you'll say if name is equal to main. If that is true, run my main function. So what this says, the name variable is built into Python. This double underscore name, it's built into Python. It aids in the scope of the code that's being executed. So if we take a look it up in the corner here, random.py is the name it's being ran. So this module or this Python file, the .py, has to be in memory. That name has to be in the main memory space in order to run. And if that's true, if everything has been imported properly and the program is then the name is equal to the name in the module, it allows it to execute the main program because this comparison statement will be true. And we see that our main function ran, and there's our output. Now, if you don't do this, it's often not seen. Some people are still there's a debate out there, and if you need it or anymore or not. It's best practices for all your future programs to put this in there. What it does is it saves you from yourself. So there'll be times where you'll be on a server running some functions, and here's the problem, or some scripts, and here's the problem. If everybody has a main function, and you may define a function called function one, well, somebody else could be running a script at the same time called function one, but in theory, there are two different memory spaces. Your random.py is in one, and their script name is in one, and that's what separates the name from yours. At times, there could be some memory bleed over, which I haven't seen in many, many years. It used to be more common when the machines weren't so robust. But now with the machines being robust, I have not seen it happen. But basically, this line saves you from yourself, and you could put a try and accept statement in here, which we'll cover later. And you catch your errors and work with your errors from this statement. But in essence, if name matches main, and this is true, this will fire, basically stating if your entire file imported properly and is ready to be ran by Python in memory, you're good to go. Nice safety check. It allows, like I said, we'll learn about try and accept later on. Now, there are other items of a function. We'll say if we just did help on def. Well, there's syntax here. Why can't I get help on def? Everybody know? Does it need these? Sure does, right? How to define your functions. Decorators, advanced topic. We'll talk about those. There's also generators. We'll talk about those. They're an advanced topic. Parameter, function names. There's a lot to functions. We're just scratching the surface of these functions. In essence, we're talking about arguments, positional arguments, default arguments. There are also things called args and quargs, multiple arguments and keyword arguments. I'll cover those next week. They're not really covered in your book. They're more advanced, not really necessary for this particular lesson. But one thing I want to bring up about your individual labs, right? This is important. You have to use functions. It's literally the name of this lesson. I'm looking for a main function defined, at least one individual function defined, and then mainline logic, right? Everything you learned up until this point, you could use with rock, paper, scissors. It would behoove you to welcome to the rock, paper, scissors Python game. Would you like to play? While play equals true, gather CPU random choice, gather input from the user and what they want to play, do your comparison operator, gather your wins and losses in a counter in global or local scope, right? Global scope is if I define a counter out here. Every function, main and say, both could access counter. If I move counter just under main, say does not know about counter. Counter is local to the main function. Now you could do things like you could say global counter. You could define one that way, or you can call on it from out here. There's a couple different ways. It's up to you on how you design your code. A lot of folks, it depends on what you're really going for, and depends on how you're going to design your rock, paper, scissors function. Now, remember, there's a couple different counters. There's a counter for how many total games. There's ties, wins, losses. So now, and if you give them the option to quit, you could say forfeit, right? So you could have different counters. If they win, this one will go up by 1. If they tie, this will go up by 1. If they lose, this will go up by 1. This one will always go up by 1 because total games played. It's up to you if you want to have the forfeit. It's up to you. Now, where you put these all comes down to your design of your program. You could put them under your main program. You could leave them out in your global variables and have a global script statements, update these. You can call on them. So if I wanted to call on one of these, let's just give this a test. We'll say global, and I'll call on C total games. And I'll say C total games plus equals 1. And I'll say hello. Then after this, I'll say print C total games. We'll see what we get here. Invalid syntax, what happened? I missed my equal sign. As usual, it's something simple, right? Thanks for letting me know. And you see that I called on the global variable of C total games, so it made this variable accessible in main. And then this is the same as writing C total games equals C total games plus 1. And then I printed it out, and here we have our 1. Awesome. So that's one way you could use this. Now, you could also bury these jokers right here. And you'll see it works too because main has access to C total games. It adds 1, it prints it out. Now, if you needed this logic in say doesn't know what these variables are because they're local to main. Just be familiar with scope, understand how it operates, leverage your code, and design your code accordingly. I think that should be enough to get you on your way between random choices, random integer, and then you have a positional and default arguments. You should be well on your way to a kick butt rock paper scissors script. Also, keep in mind, define main, and you have your main logic check. These are a must from here on out. You're going to use at least one custom function and mainline logic in every script from this lesson, lesson 4, to the end of course. Well, that's it for this evening. I hope everybody has a great day. Reach out if you need any assistance. I'll be posting this video short accordingly. Have a great night.